video will include a comparison between a swimming dive at the autonomous and associative stage and explore the skill acquisition and biomechanics involved. An elite swimmer is in the autonomous stage of learning, whereas the competent but not professional swimmer, like myself, is at the associative stage. Muscular effort. The muscular effort involved in a dive would be considered as a gross motor skill. This is because the skill involves coordinating a combination of large muscle groups with a large amount of force exerted to perform a dive efficiently. The diving block is used to gain momentum and transmit power through the larger muscle groups of the athlete and allow them to project in the air and cleanly into the water. Type of movement. A swimming dive, regardless if it is off a block or edge of a pool, is considered a discrete movement. I would classify it as a discrete because the duration is brief with one unit and a distinct beginning and end. Environmental conditions. A dive into a pool would be considered a closed skill, regardless if it was executed at an associative or autonomous stage. This is because the conditions are predictable and stable, and the athlete has control and can decide when to perform the action. If the dive was to be performed into the ocean, there may be unpredictable waves or wind to factor in, making the skill more open. If the dive was performed into an outside swimming pool, the weather conditions could impact the skill, and some may consider it more open. Generally speaking, a dive is a closed skill. Stage of skill learning. I am in the associative stage of learning when performing a dive. I am able to understand the fundamentals of my skill and can execute the dive with few errors and correct technique. I am able to detect some errors or areas within my performance that I can improve and provide feedback to myself, which can then be applied to the dive. For example, I noticed that I was breaking the surface of the water roughly. I needed to make my dive more streamlined. Therefore, my next attempt I tucked my head firmly between my arms and stretched my arms forward. This stage of skill learning is also known as the refinement stage, which I will use to refine what is needed to accomplish a dive sufficiently and, essentially, help me to consistently master the skill regardless of the situation. The elite athlete is in the autonomous stage of learning when executing the dive. This is because the athlete performs the skill automatically and does not have to focus on execution, but instead concentrate on other aspects of the dive, e.g., adequately react to external sources. The athlete is also able to identify irrelevant cues from relevant cues in the surrounding environment and react accordingly. Overall, the diver is able to perform the skill effortlessly and consistently when at the autonomous stage of learning. Feedback. The feedback best suited to a diver at an associative stage would be external, specifically augmented. External feedback is the information received regarding your performance from an external source, which could be verbal, visual, or written. This would improve the diver's performance as the external source, e.g. a swimming instructor, would have the knowledge to evaluate the skill and highlight where improvement is needed. An example of external feedback is a swimming instructor watching the diver execute the dive and provide positive and negative feedback on the skill. This is why external feedback is essential for my improvement. This type of feedback would differ from an elite athlete, as they are able to identify their own performance, knowledge of performance. The most beneficial feedback for an elite athlete at the autonomous stage would be internal feedback. Practice. The type of practice that will be best suited to me, associative stage, would be distributed practice. Distributed practice is dividing the skill and providing intervals between movements, allowing for rest and internal reflection of performance. I chose distributive practice because I am at the associative stage of learning, and closing the skill down will allow me to perform each stage adequately. For an elite athlete, distributive practice would not benefit performance, as she can already perform each stage of the skill successfully. Mass practice would be more beneficial for someone in the autonomous stage. Making the dive easier. To make diving easier for a beginner at the cognitive stage of learning, it would be beneficial to close the skill down. Closing the skill down by directing your hands into the desired destination and limiting your elevation into the water will help the beginner execute the fundamentals of a dive. Closing the skill down will decrease the input stage and, therefore, the beginner will be able to pick up relevant cues easier to perform the skill successfully. The type of motion involved in diving. The type of motion involved in diving would be linear motion. Linear motion occurs when an object or person travels in a straight line. Diving involves linear motion, as the skill does not require the athlete to rotate positioning, thus why it is not an angular motion. The specific type of motion in a dive is curvilinear, as the projectile, diver, travels along a curved path. Forces that impact. The projectile involved in a dive is the person because it is given initial velocity and follows a path determined by gravity. The forces that impact on the projectile after release and whilst in the air are gravity and air resistance. Impact of angle. The angle of a dive into the pool is crucial to a swimmer's overall performance. The angle in which the swimmer enters the pool channels the power and momentum gained from the explosive takeoff and propels the swimmer through the pool. The swimmer should enter the pool with a slight angle, as a flat entrance will not be powerful enough to glide through the water, and a larger angle will mean the swimmer will be too deep. For associative swimmers, hands should be positioned towards the other side of the pool, creating a more parallel angle and the knees slightly bent. The approximate angle of release for a dive would be 60 degrees, as it will achieve the maximum distance of the projectile person. Elite swimmers use a block to launch themselves into the water. Impact of speed. A dive generates 26.1% of power and speed over 50-meter race. The speed of the release works in relation with the angle of release, as the greater the speed of the projectile will create greater distance. Launching from block into the water at a 60-degree angle will allow the diver to exert power from their leg muscles through their body and increase their speed when entering the water. Impact of height. The impact of height is minimal in a dive, especially when referring to the height of the projectile. In saying this, swimmers who have longer limbs and therefore longer levers and range of motion can produce more in the flight phase of the dive and elongate the dive itself, creating more range. The impact of a dive when stability. Stability in a dive refers to the resistance to the curved linear movement from a balanced position. Elite swimmers grip the edge of the block with their hands, bend their knees, and have an equal amount of weight on both legs, with one leg being in front of the other, before diving into the water. The base support of the swimmer is the positioning of their feet. Before diving, an elite swimmer would ensure that one foot is in front of the other in the direction of the impending force, the dive, which increases their base support and makes them more stable. By bending their knees, the diver is lowering the center of gravity, which increases their stability. The mass of the diver does not necessarily improve their performance in the skill, although if the diver has a higher mass, they will be more stable when on the block before diving. Force summation. Force summation in a swimming dive allows the athlete to use the larger, stronger muscle groups in the central part of the body to initiate power, and the smaller muscles are used as coordination and to channel the power through the projectile. Force summation is achieved sequentially in a dive, as the body parts move in a sequence to generate great force. The force summation in a dive at an elite stage is legs, bent forward to increase stability and strengthens, creating acceleration. Core, power and momentum pass through the legs into the core. Arms act as a smaller muscle group that coordinates the direction of the dive and transmits the acceleration into the water. Impulse. Impulse is the measure of the force applied by a specific time, force times time. Impulse is important in a dive because the athlete is required to apply a larger force for as long as possible. When a diver leaves the block or pool edge, their flight time, which determines the length of their dive, is determined by the size of the force. Momentum. The total momentum in a swimming dive remains the same because it is a closed skill, although momentum can transfer from one body part to another, force summation. An athlete can gain momentum before launching off the block or the edge of the pool when they are leaning backwards and holding onto the block. This is the stage where the momentum is building and then released once the athlete pushes off the block and into the air. That concludes this video on my chosen skill, a swimming dive. I hope this has deepened your understanding and will be useful the next time you dive into a pool.